So now that we know what a binomial probability is, let's talk about how we actually find those probabilities. So just like with our normal distributions, we're going to use StatCrunch, the StatCrunch calculator, to calculate these probabilities for us. So for example, let's suppose that we're working on the example from the previous video. We're going to flip a coin 8 times, and we want to know what's the probability that we get exactly 3 heads. Well, if I go to StatCrunch and click on Stat and then Calculators and Binomial, this calculator here on the right side of the screen will pop up. And just like with the normal distribution calculator, we can plug in some information. So you're going to plug in n equals 8 and p equals 0.5. We want the probability that we get exactly 3 heads. So we want to make sure that this is an equal sign. And then we're going to plug in 3 and then click compute. And it's going to spit out the answer of 0.21875. You can always also compute binomial probabilities with a formula by hand without the calculator. So here is the formula. We're going to write BNPX. This is the probability that big X is equal to little x when we have n trials and a probability P of success. So n is the number of trials, P is the probability of success. And the formula says it's n choose x, that's what this symbol means, times p to the power x times 1 minus p to the power n minus x. Okay, so if we're doing our example where we flip a coin 8 times and we want to calculate the probability of getting exactly 3 heads, we're going to do 8 choose 3 times p, which was 0.5, to the power 3, times 1 minus p, so 1 minus 0.5, which is 0.5 again, to the power n minus x. In this case, that's going to be 8 minus 3, which is 5. And you're just going to plug that into your calculator here. This is the output from a TI 8384 calculator. You can also do this in Desmos. Sometimes we use other notation. So in Desmos, actually, it does look something like this CNX. In fact, they use NCR is what it's going to look like in Desmos, and we would type in 8.3. So let's actually do that here. So here I've got the Desmos calculator open, and I'm going to type NCR 8, 3, and then I'm going to multiply that times 0.5 to the third times 1 minus 0.5 to the 8 minus 3, which is going to give me 5. I'm going to go ahead and put 8. Whoops. No, it's not going to let me keep it in the exponent. Let's put parentheses. 8 minus 3. There we go. And that's exactly what we got when we saw the output from the StatCrunch calculator. In fact, let's go ahead and do that in StatCrunch here too. All right, so if you are in StatCrunch, you're going to click on Stat, Calculators, Binomial. So here's our binomial calculator. We need to tell it the number of trials. There were 8 trials. Probability of success is 0.5. And now I want to say x equal to, so let me click on this inequality, and you have several options. I want equals and 3. And there we go, 0.21875. Let's look at another example. According to a recent Pew poll, 47% of Americans say it is important to control gun ownership. In a random sample of 200 Americans, let's find the probability that exactly 90 Americans say it is important to control gun ownership. First of all, we should double check that this is in fact a binomial experiment. So What were our conditions? Is there a fixed number of trials? Yes. There are 200 Americans that they're going to survey. Okay, so the trials are the individual Americans that are surveyed. Does each trial have only 2 outcomes? Well, the outcomes are yes, it's important to control gun ownership, or they say no, it is important to control gun ownership. So yes, exactly 2 outcomes. Is the probability of success the same at each trial? Here's our probability of success, 47%. And that's going to be the same at each trial. And then finally, are the trials independent? Yes, when I select my next American to interview, their probability of saying yes is not dependent on knowing what the previous American said. Okay, so this is indeed a binomial experiment. So we can compute the probability that x equals 90 as a binomial probability. So remember, our notation is BNPX. N is the number of trials. There were 200 Americans, so we're going to plug in 200 here. P is the probability of success. Here, success is going to be saying that it's important to control gun ownership. So our probability is 0.47. And then X is, in this case, 90. All right, so you could plug this into the formula or into StatCrunch. Here's what we would look like if we plugged it into StatCrunch. In fact, I recommend that you pause the video and try plugging it in yourself. So when you open, you're going to hit Stat, then Calculators, and then go to Binomial. We're going to plug in 200 for N, 0.47 for P. We're going to make sure that we pick equals because we want the probability that there are exactly 90 who say yes. And then we're going to plug in the 90 here and then click Compute, and out spits our probability of 0.048. So the probability that X is 90, again, is 0.048.